I'm Ashish Lamba, Assistant Professor of Mechanical Engineering at USM, and we are in the Maker Innovation Studio, or MIST lab, at the Portland campus in the Science Building. Towards the end of 2019, we were approached by the Portland Rotary Club, which is a charitable organization in the area, who design and build these cheap prosthetic arms for people who've had their arms cut off or they don't have these arms in poor countries like the Dominican Republic and in India, and they donate these arms to those people. They have major areas of concern and major room for improvement, so what I thought was that it would be a good project for the junior design class, which gets broken up into a bunch of different groups, and each group has to come up with a designed engineer prototype at the end of the class. So the idea was to take the ideas and the designs from the Rotary Club and improve upon them and deliver something better that they didn't have before.
My name's Adam Robert. I'm an electrical engineering major here at USM. We didn't have a lot of experience with 3D printing, so it took us a while to just get used to the different materials and tweaking things to get it all working. We took different ideas, open source ideas, we kind of modified them.
But one of the big requirements was fitting it within a budget, right? So these assembled prototypes and this final prototype that you see over here can be made for $110, which is pretty cheap for a prosthetic arm, which actually actuates. These arms also have to function in the Dominican Republic and in India, which have very hot and humid climates, so they had to be careful about the materials that they chose.
Started off with this red prototype, which is kind of a couple different designs. The hand was another open source design, which was mechanically operated.
If last semester would have gone off ideally, it would have been much easier to do because the students would have had access to campus and all the facilities that are here in the Maker Innovation Studio and also in the John Mitchell Center. Because COVID hit and the students had to continue to work remotely, only 2 out of 7 groups in the class ended up with a final prototype. Everyone else just ended up with designs that they submitted that I graded them on.
Yeah, we didn't know what was going to happen after spring break. I just bought an inexpensive just 3D printer that works just as well as some of these more expensive printers here. With 3D printing, there's a lot of failures, just part of the process. I was doing the printing and assembling pretty much on a rolling basis. As soon as stuff was done printing, I got it ready, cleaned it up. So every time we had a Zoom meeting, I would show them the progress of where we're at, what we needed to do next. We communicated through group text most of the time, but we also had Zoom meetings ourselves. The challenges really were trying to get the pieces printed without being able to come into school and use other computers, also getting together to be able to operate. I gained a lot of knowledge from this.
The students had to develop skills in design and in computer modeling, and also learn about how electrical actuation works, how these servo motors work, what the pros and cons are of the different materials that they're looking into. You have to have an all-round engineering mindset to be able to make something like this. For a group to go above and beyond and actually deliver not only a complete design prototype, but also a functioning prototype with all this electromechanical actuation was above and beyond the call of duty. We hope to continue making improvements and continue delivering better prosthetics to the Rotary Club.